Good evening, Advanced Math. Going to use our knowledge of expressions today to start doing some practical stuff. And so we're going to start today by expressing and calculating discounts. I'm going to show you two strategies for doing that. Okay, so find the next free page in your math notebook, write down your title. When you've done that, close it up and listen to me till we get to the we do. All right, a couple things that are going to help out here. One, let me remind you, fraction, decimal, and percent. We learned in our last lesson how to go back and forth between the three. Today, when we calculate discounts, they're usually a percent. You'll see something like 10% off. And so what we're going to, it'll be helpful to be able to turn that 10% into a decimal and or a fraction. To help you out. So remember, a percent, that is a ratio out of 100. So that is, 1 out of, that's not the decimal. That's the fraction I'm going to go to. It is a fraction of 100, so that is 10 out of every 100 off. Like for every $100 the thing costs, $10 off. Or for every 100 cents it costs, 10 cents off. And then 10 100ths is easy to say as a decimal, which is 10 100ths. So we're going to be doing some of that today. Just need to be comfortable doing that. And so variables we usually use for unknown values. Today I'm often going to use a variable for a known value. Even though we know what it stands for, you're often going to see me today use a variable for the price. Even when we know what the price is, to simplify what I'm looking at and express what I'm showing you, I'm often going to act like I don't know the price till the end of the problem, and so I'm usually going to give it a variable, probably P for price or C for cost, something like that. Okay. So here we go. So first example, how much will a $24 shirt cost if it is 25% off today? So that's a common thing. You go shopping, you see the cost of something, and it says it's 25% off, but they don't tell you what that new price is. They just tell you, the original price and the percent off. So I both want you to get used to showing and expressing and calculating problems like this. Not just being able to crunch the numbers. I also want you good at kind of showing it and expressing it with algebra. So I'm going to kind of go through all of those steps here. So I have two strategies to do it. One of them is going to be you just find the discounted amount. How much is the percent off? And then take that away from the price. Second strategy is just going to be to calculate the rest of the price other than the discount. So I'm going to show you both. So the first thing to do to show this situation, the situation is going to be, I'm going to do that up here actually, because showing it's kind of the same for both problems. So I'm going to start with a tape diagram, which it's been a long time since we've done. So if you want to imagine, this is the price of the shirt, and I know that price is $24 because that's in the problem. And it's 25% off. So 25%, you probably know that as a fraction. 25% is one you probably know. Remember, that's 25 out of every 100. And if I divide both by 25, 25 out of 100 is 1/4 of the price. So it's like 1/4 off. So if I think about my $24 shirt in fourths, each of these is a fourth of it, and I'm trying to figure out how much is off. So this is just a way to kind of think about the problem. So basically, this part is going to be discounted, 1/4 of it, and I'm going to pay the other part of the price. So with the tape diagram, you can probably already calculate it just looking at this, right? I have $24. If I divide it into 4 parts, each part's going to be $6. And so it's $6 off. So this is the discounted price, and this is the part I'm paying right here. The other 3/4 is the amount I'm actually paying for the shirt. So I'm going to pay $18, and I'm going to be discounted $6. And so actually, I've calculated it already just from the showing, from the drawing. And so I want to start with that. It's kind of funny here. I'm going to, we've already calculated the price. Calculate. So the calculation here is going to be done because I want the algebra part to make sense when you already know what's going on. So we're going to pay 18, and the discount was 6. So the answer to the question is $18. And the diagram helps me do that and make it clear. Okay, so let's talk about expressing it. We've been learning a lot about expressions, and so I want to go over that first. So strategy 1, find the discounted amount and subtract it. So up here, calculation-wise, that was, well, the original price is $24 minus the discounted amount of $6 is $18. That's my calculation if I'm just going to crunch the numbers. So let's talk about showing it. So I'm going to act as though I don't know the price here. So let's just say the cost of the shirt is C for cost. And I'm going to take away 1/4 or 25% or 25/100ths, whichever way you want to put it. So my expression for the total cost after the discount is I have the cost of the shirt, take away minus 1/4 of the cost. 1/4 of the shirt is going to be taken away, or cost minus 25% of the cost. So either of these expressions shows me how much the shirt would cost if I don't know the price. If it was $50 or $24 or something like that. So I can calculate it up here since I do know it, but I also want you to be comfortable seeing or writing down the cost of the shirt in this way. So my first strategy is to find the discounted amount. In this case, it's $6, and then take it away from the price. $24 minus the 6 is 18. Or cost minus 1/4 of the cost. Cost minus 25% of the cost. So these are expressions to show how. My second strategy is just going to be to calculate the remaining amount. Instead of 2 steps here, where I say, okay, well, I'm going to just calculate the 6 and take it away from 24, I can say, well, if it's 25% off, if it's 1/4 off, instead of focusing on the amount I don't pay, I can just look and say, well, I just pay this much. I pay 3/4 of it. I don't pay $6, but I do pay $18. So it's really just looking at, 3/4 of the $24 is $18. I just look at the price I do pay. Or if you want to say if it's 25% off, that means I pay 75% of the price. I don't pay 25, I do pay 75. So in this case, still the same cost of $18. I'm looking at the cost I do pay. So my expression could be, rather than knowing the whole price and taking away 1/4 of it, whole price, take away 25% of it, I could just say I'm going to pay 3/4 of the cost, or I'm going to pay 75% of the cost. So it's a much simpler expression. A whole cost minus 1/4 of the cost is 3/4 of the cost, or a whole cost minus 25% of the cost is the other 75% of the cost. But it's just a one-step thing. I can say, well, it's just going to be 75% of the 24 to get 18. Or it's just going to be 3/4 of the 24 to get 18. Rather than finding 24, take away, 25% of the $24. So it's just a simpler expression. So two strategies: find the discount, take it away, or just calculate the amount that you do pay. All right, let's do one together. See if that clears it up some. So if you wait until Christmas Eve, you can buy a Christmas tree, which is usually $60, for 40% off. What a deal. How much does a Christmas tree cost on Christmas Eve? All right, so I'm going to move that up so I can show it. So let's find the price of a Christmas Eve tree. So let's just make a nice tape diagram up here. And this whole thing is going to represent the $60 Christmas tree. And 40% is 40/100ths, or 4/10ths, or 2/5ths as my simplest possible fraction for 40%. So I'm going to divide my tape diagram into fifths. And each fifth is 1/5 of $60. 60 divided by 5 is 12. So each fifth is $12. So 2/5 is my discount here. 40% off is 2/5 as a discount. So I might, maybe kind of do two colors or something here. So this part, 2/5 is my discount. And the other 3/5 is the amount I'm going to pay. It's like my the price you still pay, the new payment, the new price. So I've already calculated the answer here. So I'm not even, it's going to be pretty easy for me to think about it now. I know the answer. It looks like I'm going to save $24 and I'm going to spend $36. So strategy number 1, calculate the discount and then subtract it. So when you're just calculating this, I take my $60 price and subtract the discounted amount. So I'm going to take away the $24, which means I'm going to pay $36. So that's strategy number 1. Calculate the discount and just take it off the price. And to show that with some algebra, express it. What I did there, I took the price of the tree, P for price, and I took away, whoops, I don't know what happened there. The whole thing skipped. I took away 40% or 2/5 of the price. So I either took away 2/5 of P, or you could do it with a decimal too. You could say the price minus 40% of the price. So these are expressions to show me how to calculate it for any price. It doesn't have to be $60. All right. So my second strategy is, instead of taking away from the original price, just say, okay, well, if I'm saving 40%, that's the same thing as spending 60%. I spend the other 3/5 that I don't save. So I'm saving 2/5 and I'm spending 3/5, which we already calculated was $36. So if I wanted to show that with algebra, instead of taking the price and taking away 2/5 of the price, I'm just spending 3/5 of the price. Or instead of signing the price and taking away 40% of the price, I'm just spending 60% of the price. So I would do, 3/5 times 60 is $36, or 60% times $60 is $36. So that's two ways to show and calculate the price of a discount. That was two quick examples. Please go back and watch them again if they were confusing. I am out of time, so I got to let you go. So please watch these again if you need to. Otherwise, see you tomorrow.